Hello, YouTube viewers. Welcome to Scale Conference. And today I am with.
My name is Dev Bhise.
So Dev Vise is gonna present a very unique sky cool technology. Basically, the idea is we have a structure, and this is a like normal structure. So assume this is the sun, and as you can see, sun is radiating in infrared and everything. And the outer surface of your concrete structure, घर का जो छत है, outer structure is going up to 73 degrees Celsius if you do not do anything. But if you apply his coating, you can see the temperature drops a lot. It can easily drop to 57, and that's just the outdoor temperature. Because the outside of the concrete is cooler, the bottom side also cools down. It drops to 53 compared to 60 degrees Celsius. So this allows us to achieve cooling without expending energy. So sir, can you explain how does this magic work?
Amazing. So first of all, thank you Anupam ji for visiting us. This technology is called as passive daytime radiative cooling. Passive because it doesn't use an active source of electricity. Daytime because of course the cooling has to happen in daytime वरना उसका मजा नहीं है. Radiative because the primary mode apart from reflection is radiation or high emissivity of the material. Now what happens over here is this surface has got a good amount of reflectivity, so the incoming heat is reflected back. This is where normal heat cooling coatings work.
Okay, so this makes sure that sun cannot deposit energy into the structure.
And plus what happens is after that, this coating also has very high emissivity.
Okay.
So the fraction of energy that is absorbed or that is there is also radiated back to the atmosphere in the 8 to 13 micron spectrum, which means it goes directly out to the outer space.
Okay, so that's the main thing, because almost everything that absorbs heat radiates it away, but our atmosphere reflects it backwards.
Yes.
We call it greenhouse effect. Awesome. So your trick is that you are reflecting in a window that allows that IR to directly couple to vacuum of space, which is 0 Kelvin almost.
Almost 0 Kelvin.
Yeah, let's just call it absolute zero. So this basically couples your structure to infinite, basically almost infinite heat sink.
Yes.
You do not have to worry about it. It's just like, bro, dump as much as heat you want, but the outdoor, basically you're not heating the universe. So
yes, we are not heating the universe.
Yeah, so the benefit is, first, sun cannot dump heat into it. Second, the heat that it is radiating, it's radiating in such a way that atmosphere cannot reflect it back.
Exactly.
Okay.
Exactly.
So what are the challenges that you had to solve in order to make this magic?
So when we started out, first game was to make it reflective, and in doing so, make it glossy. The common challenge with glossy coatings is बाहर से अभी small scale it will look amazing, but when you have a whole roof which is glossy, you will never be able to walk on it because the glare will get into your eyes.
Yes, it's a hazard. It becomes a hazard.
Yes. The essential rule book that we followed, because my co-founder is an architect, so she gave us a MVP, a minimum viable product that had to be made, where we had to achieve the functionality with minimum gloss, with minimum added whiteness, that we don't have any organic fillers added to it to give it more whiteness. The ceramic material itself is of this color, which is why it has this color. So when we started working on it, getting to the MVP itself took us around 5 years.
Oh, so it took a long research. Now, a lot of people have tried with nano films, but turns out they are not very scalable. You can't just paint them. That had to be grown very specifically. And some companies have also tried with microspheres in order to achieve something similar. So have you experimented with those, and like what was the pros and cons of that?
I'm really happy to see that you've really gone in depth into the technology, Anupam ji. Yes, microspheres was a very tempting line to go down. The challenge with microspheres is that, in places like India where there's a lot of dust, there's a lot of dirt, and there's going to be a lot of foot traffic. Microspheres are generally a very tough proposition to handle because dirt cannot be cleaned easily once you have a microsphere surface. The second challenge is India has a lot of foot traffic. So over there, microspheres generally are a little vulnerable to that because they are not good at taking the compressive load. Whereas what we work on is essentially not having those technologies, having fine granulation, fine grains, almost bordering on nanotech if you were to say. The advantage of our technology is that it is very rugged. Like we have done temple walkways, जहाँ पे शिवरात्रि के दिन around 17 to 20,000 people have walked on it, and there has been no damage.
Okay, so this is solves one of the biggest issue with this sort of radiative cooling. It makes it robust that you can actually apply and forget about it.
Almost.
Yeah.
Almost.
Okay, now let's talk about the lifespan. Let's just say I did this coating. How long should I not worry about it, basically?
We say the lifespan will be 3 to 5 years. And we say that with considering that Indian atmosphere is very full of dust, we also have a lot of foot traffic. Also, you're going to have a lot of rains. We are not a dry country. We are a country with the maximum number of monsoon in the world. Like if you see, the monsoon cycle that India has it sees the maximum amount of water being dumped from the sky on the plains.
Yes.
So considering all that,
Uh-huh.
still we say 3 to 5 years.
Uh-huh.
If you were to go at a place where the monsoons were not that bad, or if you didn't have that kind of dusting, probably the life would be 7 to 8 years as well.
Okay. Now let's just say we applied it, and of course, let's just say for maximum performance level, I'm willing to redo it every 3 years. Now let's talk about its effect, as in, like, is it toxic? Is it made out of materials that are very hard to recycle? Like, okay, now let's go into the nitty-gritty of it. What it is made out of, and like, are there consequences? Like, does it have lead like old paint used to have? So dive deeper into
great.
that.
So if you see, the lead content in our coating is less than 0.1 ppm. And ppm, just for your viewers to give a little more technology of it, ppm is milligram per liter. Not even grams per liter, milligram per liter. And our lead content is lesser than 0.1 milligram per liter.
Okay, so do you add lead to it, or
No,
like
it's less than 0.1 milligram.
as in, like, it may be a contamination from some other processes? Okay. Okay.
The industry standard for lead free is around 200 or 100 ppm.
It's that high?
I think so. But you'll have to see what they define as lead free or what it is. But certainly we are beating a whole lot of things because ours is less than 0.1 ppm.
Okay. What's the core material on this? Like, what is it? Iron, alumina? What is the core material on this?
See, that technology is difficult to share because it's the proprietary technology.
Special sauce.
Yeah.
You're not gonna share the special sauce.
So it's my grandmama's special sauce. No, see, it contains ceramic materials. The second aspect of it is it obviously has to have a binder, but the binder and ceramic have been designed in such a way that they support each other rather than working against each other.
Okay, so how a customer can use this, basically? What a customer is gonna get? Like, customer is gonna get a powder from you or a tub from you? What customer is gonna get from you?
So customer is going to get this in form of a liquid, which is like a paint. They will have a primer, a base coat, and a top coat, or depending on the grade, a primer and a top coat. So first they have to do is clean the surface. We highly recommend brushing and water jetting because that really cleans your surface. If you have any residual cracks in there, you need to do the maintenance and again wash it. After washing, put the base coat of primer. I'm talking of RCC roof. Put the base coat of primer, then the base coat and top coat can be applied by any painter. Doesn't need to have special set of skills.
Okay.
If you're doing a metal shed, then you don't need to have a primer. You can directly use the base coat and top coat.
Okay.
But cleaning is a must.
We clean it first before applying it, and after it's done, it's a normal roof.
It's a normal roof.
We don't have to worry about too much about it.
But pre-summers, if you do a water jet cleaning, that will really help you get good results because you're cleaning the surface off, so you're getting the full surface to radiate the heat back.
Okay. So have you deployed this in anywhere where it's like hot?
Yes, we have done trials initially in Hyderabad. We have done full-scale projects in Hyderabad and Navi Mumbai, which is close by. We have also done projects in Pune, and we are right now in talks to do a large surface area in Pune itself. We did their pilot. They were very happy with the result. Now we are going to do the whole facility.
Okay. What are the limitations of this technology? Because I've been told that once we have clouds or once we have a high moisture content in the air, the water vapor basically closes that window, that IR window. So do we have some limitation like this?
So yes, as far as clouds are concerned, on a cloudy day, yes, the delta will be lesser. On the moisture front, it is not too much of a challenge for us because, see, we are a company that started out in Mumbai. We are right by the sea. So moisture is something that we work on day in, day out. So when we were building, automatically resistant to moisture came in by nature. So, but you are right. Compared to Navi Mumbai, which is close by the sea, if you look at the site in Hyderabad, the deltas are much better because over there it's dry.
So if I live in a dry and hot place, I think this will be a perfect technology.
It can be a dry and moist place also, but you will get awesome results in hot and dry.
So if it's dry, I do not have to worry about it. Put it and forget about it. It can easily last 3 to 5 years.
Yes.
And now let's talk about the cost. This is the most important part. If it's like magical technology, I can't afford it. What's the point? So talk about the cost.
See, we have two models that we do. One is looking at how the Indian market is structured and looking at the needs of people. We have two grades that we have come up with. One is a pro grade that is around 35 to 40 rupees square feet material cost. X Works Mumbai plus GST, of course. We have a premium grade which is 45 to 50 rupees square feet. X Works Mumbai plus GST, of course. The beauty of this is you can have your own painters do the job. You don't need to call a specialized team from Mumbai to do the job for you. Any painter who knows how to wield the paintbrush and who has good sense to apply the paint uniformly can do the job for you.
How many coatings after the primer you are expecting for maximum result?
3. 2 base coats and 1 top coat.
Two base coats and one top coat.
Yes.
So this is how we're gonna do it. And can people apply this on the sides also? Would it be useful?
It would be useful because you would cut out the heat ingress over there. Especially, we have a client who did south and southwest side. So what he reported was the way his house used to get very hot in summers. It doesn't get very hot in the late afternoons in summer. Okay. We have a video from him in Marathi. I'm not sure if you follow that. Whereas he's actually exclaimed with joy that he's sitting without AC in summer.
Wow.
And
in India, that's a big deal.
That's a big deal.
It's a big deal.
And we have also had worked with HNI clients whose roofs and side walls also we did. And there also the same effect was observed.
Because sidings have to face the issue that they are not directly looking at the sky, so they do not have full area. But if it can reject heat, basically not absorb heat from the ambient, at least that would be useful. So
that's very useful.
So
plus the beauty of this coating is, see, anyways people do waterproof treatment. This is a built-in waterproof material by itself.
Okay, now we are talking about this.
Yes.
So this can handle moisture, not because it's like we have special sauce. The sauce itself is waterproof.
Yes.
Okay.
And with waterproofing, it's also good antimicrobial features. Like it is resistant to algae, fungus, and moss. Unless you have water which is on it. If your slope is not correct and you have got water deposited on it, then of course you will have fungal growth. But by itself, you will not have algae, fungus, moss growing on it.
What are you using in it? Are uranium or something?
Well, I mean, we are using certain ceramic properties. See, I come from a ceramic background and a material science background. So whatever limited knowledge I have, the 0.1% of a sector I have that is in ceramics. And I've been blessed that ceramics have these kind of properties if you process them in the right way.
Okay, important question. Can you scale this up? Let's just say tomorrow India realizes that we need this. It's not optional. We have to have this. Can you scale it like megatons per year? Can you actually manufacture? Like, do we have the raw ingredients that, let's just say somebody gave you the venture capitalist fund that you need to scale it up? Can you actually do it? Or does it require special, minerals that we do not have? Like all the minerals, can you manufacture that in India?
See, now everything available in India or everything not available in India is now starting to become a very gray zone kind of a definition, because everyone has to look at what is viable, what is technically and commercially viable, and what is what is scalable. When you talk of megatons, you take any chemistry in India, very few players have the capability to have that scale. But if you have to look at overseas, US, UK, Germany, even over there, very few people have those kind of capabilities. So tomorrow if the thing comes in, yes, we will need to do some work to scale it up. We are doing it in tons level. But if someone says megatons
or kilotons, let's just say start.
Yeah.
So
we are already doing like we have a contract manufacturing where we have the capacity to process 1.5 tons per day. That is 40 tons a month.
Okay, so let's just say 1 ton. How much coverage you gonna get from 1 ton? Like, are you talking about the pigment, or like is there a binder in this, or like you are talking about the whole
mix? Our selling product is the capacity right now is 1 to 1.5 tons per day, and in that 1 square foot covers 1 kilogram covers 25 square feet. So 1 ton.
So decent coverage. Like I think for early scale up, I think this is more than good enough. We can scale it up. And do you see the ability to scale this in other places? So right now, I'm pretty sure this is in Mumbai, right?
Yes, this is in Mumbai. In India, we are doing, but we are in talks to do a pilot in Spain, and we are also looking actively to get some entry in the Middle East, because that is where they would need this very drastically.
Yeah, because most of the Middle East could be dry also, not only hot but dry also, which I think magnifies the temperature delta that you're gonna get.
And it's not just hot; it is very hot and very dry.
Yeah.
Because ambient over there hits 53, 54 degrees in summers, which is around 5 to 6 months of their year. And over there, the rooftop temperature, what we're seeing over here in our demo kit as around 73, their measured rooftop temperatures over there are between 78 and 80.
Yes. Oh, and can you please talk about like what are the add-on benefits that we're gonna get? Let's just say I did this and I put a normal bifacial solar panel on top of it. What are the benefits I'm gonna get?
So what happens is, I'll just go into a technical part a bit before I answer that. On a normal rooftop, when you put a solar panel, your roof is already hot. Now let us remember that solar panels are an invention of the West, where the ambient temperature barely crosses 30 to 33 degrees on a normal day.
On that important note, who is doing ISI in India? Why the heck Indian solar panels are rated at 25 degrees Celsius? Why? Who is responsible for this? I need to find that person. it should be rated at least 50 or 75, not 25. I have no idea how the heck which Indian roof is 25 degrees Celsius, how the heck Indian solar panels are rated at that. But he raises a very important point. If you are deploying in Middle East or even Rajasthan, 70 is like normal. Like if you put anything on your roof, 70 degree is like expected. So yeah, that was just rant away, dive deeper into it. It makes me very angry. It's like, why 25 degrees Celsius?
That's because that's a universally available temperature.
Yeah, but not useful for us.
Yeah, I mean, yes. So what happens is with that rise in temperature, when your roof is at this temperature, see, and on an average, you can see videos that are there. Your average summer roof temperature is between 65 to 70 degrees. At that point of time, you are transmitting heat back to the solar panels and effectively diminishing their effectiveness. If you have a cooler roof, you're passing on lesser heat to the solar panels, so your efficiency goes up. The same way, when you have a bifacial solar, what happens is you have got this reflects the light back to the panels, but at the same time it doesn't radiate the heat back because the heat radiation is happening in NIR spectrum and not the FIR spectrum, which does the heating part of it.
Oh, this part is very important. As he talked about, there are spectrums inside infrared. Infrared is a very wide zone.
Yes.
We have like 3 zones, if I'm not mistaken, inside that zone. And not all infrared behaves the same. Some are easy to reflect, some are easy to convert into electricity, some are just heat. You cannot stop it. So whenever concrete like this absorbs certain way, basically energy, broad spectrum energy from the sun, it radiates it in a wavelength that you can't really stop. That's why your solar panel gets fried. So this basically removes that coupling efficiency. It will no longer radiate the infrared that solar panel cannot handle. So that's how you're reducing the temperature. You're not cooling it. It's just that you're not cooking it.
Right?
Right?
Not cooking. Absolutely.
Yeah,
I love that. You're not cooling it, but you're not cooking it either.
Yeah. So basically, it's almost like it's on top of a water body or a mirror body. It's a mirror because
it's a heat reflector, heat
yeah.
radiator, as you can see.
Yeah. So I think this is a very impressive technology. And again, given the temperature, I think we need this. This is not optional. And I'm definitely looking forward to installing this in my rooftop because I need this. So again, this was a very nice conversation with you. And do tell me the special sauce. I would like to know the special sauce.
Sure, sure.
Okay.
And so, it's a pleasure to have you, Anupamji.
Okay.
It's been a long time that I spoke to someone who understands this depth of technology. So really honored to meet you, Anupamji.
Okay. So can tell us how people can find you, basically your company and
yeah, you can look online for a product called as Ganzkuhl, which is basically this Ganzkuhl. You can look it up for us, or you can find us at Q Sustainable Technology website, which is qsustainabletech.com.
Thank you. I hope you guys liked it, and I'm gonna buy this now. Bye.